So I'm going to get that down right. So when to walk out on stage. Hello, everybody. Everybody awake? Can I get a whoop whoop? All right. You guys are beautiful. I love seeing you guys. Okay. I want you guys to welcome Austin Federa to the stage, like with a real shout, applause, and a whoop whoop. 1, 2, 3. Okay, Austin Federa.
There we go. That's a bear market whoop whoop if I've ever heard one. Well, hey, I'm Austin Federa. I am one of the 3 co-founders of DoubleZero. And DoubleZero is a bit of a different type of crypto infrastructure project. So what we're doing at our core is we're trying to build a new internet. And we're trying to build a new internet from first principles, which is that the existing one is great for a lot of things, and it's not great at a lot of other things. So if what you are trying to do is secure and synchronize Bitcoin, if you're looking at a roughly 21 transaction per second, 12.5 second block time L1 like Ethereum, it's great for all those use cases. But if we actually want to compete with traditional finance and traditional Web 2 platforms, none of that actually runs on the public internet. You might think that Facebook and Google and Meta and all these companies run on the public internet. They don't. They run in private data centers, and they have some of the largest private fiber lines of anyone in the world. And so we started from first principles, and we said, if we're going to try and rebuild the internet suitable for fast execution environments, whether that's L2s or Solana or other alt L1s, we really need to look at performance first. We have to build something that has decentralization and censorship resistance built in, but not over-optimized for that, the same way that L2s do not over-optimize for that. And so this is where we came up with DoubleZero. So what is this network? At the end of the day, it's a deeply physical infrastructure network. And so this is a pretty famous GIF of a shark biting a subsea fiber cable. This is what the DoubleZero network runs on. It is a physical infrastructure protocol, OSI layer 1, 2, and 3 in the stack. This is far below anything that you currently engage in blockchain, with the exception of like ASIC miners on Bitcoin. And so we're talking about, these are physical DoubleZero devices. This is a high performance sort of off the shelf switch made by Arista. And what we're building here is a physical fiber infrastructure network that scales across the globe, reaches almost every market that we see significant amounts of blockchain infrastructure run in today, and can do this much faster than the public internet. So what do we mean when we say faster than the public internet? So the internet was not built for high-performance systems. It's built for low-cost reach, and it does a beautiful job at that. For $40 a month in New York, you can get a gigabit of internet that can talk to any other server anywhere in the world, and that is a monumental achievement of capitalism, but it's come at the expense of performance. So what we have here is we have real data on the internet versus DoubleZero. This is from LA to Singapore, 24 hours of tracking. So what you see here, all of this variability in ping time, this is jitter. And jitter is a measurement of how unstable a connection is. So we're all familiar with ping time. Ping time changes and drifts moment by moment and hour by hour. And so that's what's referred to as a system's jitter. And you kind of have this like large error band, and you can actually see the error, the average latency jumps up significantly at this point in time. This is when the ISP just decided to route our connection over a different pipe, like literally a different physical cable in the ocean that had worse performance than the thing we were on before, and that continues, and you see these random spikes all the way up here and then down here. And all of this is a killer for high-performance systems, right? If you build a high-performance system, what you want is serialized data streamed into it consistently in the order that it needs to be processed. And everything about the public internet makes that extremely difficult. This blue line along the bottom is the DoubleZero network. So not only is it lower latency, but it's got functionally zero jitter on it. And this is used by all of the world's tech companies, all the world's trading firms. Basically anyone who's building anything serious in the traditional space uses private dedicated infrastructure because it's much more dependable and much more high performance than the public internet. Today in blockchain, nothing runs on it. So we set out to build a network suitable to run all it. So this is the DoubleZero network today. This is fiber contributed by 15 independent contributors. So we build a software protocol, a blockchain protocol, that allows independent contributors to mesh together fiber connectivity. So this represents about 8.8 terabits per second in total capacity, which is enough to run every blockchain in existence tenfold on the network today. And the whole point of this is to allow folks to build systems that go faster and are more decentralized than the current high-performance architectures of today. So if we go to the next slide here, this actually shows you what entity is contributing the fiber to the network. And you can see there's this quite dense network of multiple independent contributors. And so in many of the top locations, you have a form of censorship resistance and decentralization. We have 3 different providers bringing multiple different pairs of fiber into this city. And so even if one piece of fiber goes down, if one provider decides they're going to censor you for some reason, there's lots of other alternatives to deliver data. And this is really like the scale of infrastructure we need to be thinking on if we actually want to compete with traditional finance. Like today, we talk a lot in crypto about competing with traditional finance. We do a very poor job of actually competing with traditional finance. Price discovery happens almost exclusively on Binance for almost every asset in crypto. The most successful crypto products in TradFi are stablecoins, which are great. I love stablecoins, but they're a completely non-competitive use case. Payments happen and payments have to happen, but there's no competition in payments. No one is trying to snipe you or take your liquidity or win a trade out over you. And anywhere where there's actually serious competition, traditional finance still runs circles around every execution layer in blockchain today. We're excited about 10 millisecond block times or 10 millisecond pre-confirmations, and that's an eternity compared to the nanosecond scale traditional finance is operating on. And so if we want to actually start competing with these folks, we have to go back to the base layer and say, what infrastructure is this running on? Most L2s today deploy their infrastructure in cloud providers. Almost every single one of them is built in a cloud. That's also true of most crypto exchanges. Pretty much no traditional TradFi exchanges are run in the cloud because the cloud has huge performance hits and latency involved, even within these systems. This is why you'll have 10 or 15 milliseconds of jitter just in an AWS data center. And so even when we sort of in crypto say, well, we're going to compromise on decentralization for other characteristics, we're doing it in a way that doesn't actually get you all the performance benefits of that. And so the DoubleZero network, it's live today. We launched it in October, and we have a bunch of real-world data on how much faster it's performing. And we started off supporting just one network, but now we're at a place where we're able to support all types of blockchain systems as well as non-blockchain systems that are interested in running on the network. And I'll go into a few of the other characteristics of it. But just to kind of go back, like everything in blockchain basically happens at like layer 5, 6, and 7. This is way further down in the stack. And so when we're doing these optimizations, it comes from a very different place. So again, I said, this is a blockchain protocol at the end of the day. There's core contributors to it, which are the people building the code. We have network contributors. It says 11 here. We're actually up to 15 at this point. These are the entities that are actually contributing fiber to the network. So this is a sort of type of DPIN project. And then we have users, which are validators, RPCs, traders, anyone who needs to communicate data faster than the traditional internet allows. But we can do better than that. So we can use multicast on networks like DoubleZero. Multicast is a technology that's been standard in most traditional finance for 10 to 15 years at this point. You have run into it in your own lives. It is how Sonos gets one copy of the music from your phone to 10 speakers in your house, Chromecast, AirPlay, they all work the same way. This is hardware acceleration of packet replication. So in a unicast world, every single destination a packet wants to get to is another data stream. This is why there's a tax. Every additional node in a network requires more bandwidth for the person sending it. And so either you need a huge amount of bandwidth on the sender node, or you have very complicated, very slow P2P data stream trees that propagate data all throughout a network. And this is why if you're running flashbots or something like that, you are locating next to the majority of the block builders so you have that data as quickly as possible. The beauty of multicast is the network switches replicate the data on behalf of the users. And so you can have multiple subscribers. It's very similar to like FM radio or something like that, where the number of listeners does not increase the amount of bandwidth used by the system. Multicast has been, this is the way that like traditional exchanges distribute price feeds. This is the way that YouTube and Amazon and all these companies move data around their private networks when they have to get it to multiple locations. This is how every single high-frequency trading firm in the world manages their data movement. It's not possible on the public internet. So you need all the fallbacks. You need the ability to run through libp2p or Turbine or RaptorCast or any type of state distribution system. But we can go faster than this, and it's time we actually start taking this stuff seriously, because if we want to compete with traditional finance, we can't be limited by running on technology that was fundamentally designed in the 90s for a very different internet structure than it is today. It's an achievement of blockchain that we're ready to do the thing that every major software company has done, which is grow up on the infrastructure layer. Facebook started off just building a software platform. Then they built their own servers. Then they built their own server racks. Then they built their own data centers. And now they're building their own subsea cables. And this is the journey of pretty much every successful technology company. Crypto is successful enough that it needs to start doing the same. We're already starting to build custom chips, right? There's from ASICs was the first implementation of this, but we have zero-knowledge prover chips now. We're getting into hardware as an industry, and the connectivity layer is going to be one of the massive unlocks that actually allows these blockchains not just to support 100,000, 1 million transactions per second, but to do it at speeds that are competitive with traditional finance, move price discovery off of Binance and back onto blockchain where it belongs, and actually start competing when we talked about tokenized equities. One of the questions I love is like, why is there functionally no foreign currency trading on blockchain? We have stable coins in all these international currencies. Functionally 0% of the FX market trades on chain. It's too slow, right? These are small basis point trades where a little bit of price movement really matters. And today, there's no blockchain system fast enough that where any serious volume of FX trading takes place. That's a failure. That's like, we've done all this incredibly great work in blockchain, but we're still not fast enough to really compete with traditional finance on trading. So where are we today? We launched our mainnet beta, which means there's still a few components that are more centralized than we'd like them to be for the long term. We've rolled out a bunch of new features on the network, and we're looking forward to a mainnet coming up. But even with mainnet beta, which is a permissionless network that anyone can join, we have a bunch of examples on Solana of how we can speed things up. So this is state propagation on Solana. This is a very Solana-specific graphic, but effectively on Solana, blocks are 400 milliseconds, and any alpha you can get on what's changed in the network is very important for trading. And so what we see is we have, across the board, hundreds of milliseconds of improvement, even within data transmission within Europe, let alone when we're talking about synchronizing data around the world, where this increases even more. By using multicast, Jito, which is sort of a MEV system on Solana, they were able to reduce their bandwidth usage by 99.96% using multicast. And so if we look at scaling up these systems, this type of bandwidth savings is really important. This is the approximate difference between this pool of water and this swimming pool. So this is where we're at. This is where we're starting to build things for high-performance systems of the future. And so, at this point, we're talking with a number of L2s as well, a bunch of Oracle systems about adopting the DoubleZero network as an infrastructure layer. If you're building stuff, if you'd like to talk, I'll be around afterwards. And you can learn more at doublezero.xyz. Thank you.